Hi everybody, I'm Praveena and I'm a third-year graduate student advised by Bilge Mutlu and Michael Gleischer at the University of Wisconsin-Madison. I work on developing human-robot interfaces, particularly for robots that carry out physical interactions with objects or humans in the environment. Let us now see a clip of an example of physical interaction. Oops! Needless to say, unpleasant things can happen if robots do not apply the right forces while interacting with objects and people. So we propose to develop novel human-robot interfaces that allow users, especially non-programmers, to specify and interpret a robot's physical interactions. In this talk, I'll discuss briefly about one work in the area of specifying physical interactions through demonstrations of tasks by people. Another work that I'll discuss is in the area of interpreting a robot's physical interactions, where we study a novel way of providing feedback about forces in a remote robot environment. In our first work, we laid out a framework to help characterize input methods for demonstrations given by humans to specify what the robot should do. We outlined a set of criteria that can be used to create or select input methods that best fit a use case. Using this framework, we also evaluated our novel input device called instrumented tongs that can capture both kinematic and interaction force information from human demonstrations of manipulation tests. The design of the tongs is intuitive for untrained people to use and allows them to use manipulation strategies that are relevant and can be mapped easily to robots with two-finger parallel grippers. In our second work, we explore new methods of providing the user with feedback about forces experienced by the robot. Motion controllers have been used in recent years with great success to teleoperate robot arms. However, these systems provide minimal force feedback to the user. We augment this system with visual motion cues to provide a force-like feedback. For example, when we want to convey to the user that the robot is lifting something heavy, we slow down the robot motion as compared to the user's input. We also show that users not only observe the visual motion cue, but integrate it with their proprioceptive sense of where their arm is in space during teleoperation. Referring to our research goal again, the two interfaces that I just talked about, one for specifying robot manipulations and the other for interpreting them, are examples of various distinct modalities that we have explored in our lab to design new interfaces. We want to leverage this in our future work to build multimodal interfaces, specifically interfaces that can adapt to the context in which the user and robot operate. Thank you for your time.